Hello, my name is Dave Peterson and welcome to TC LIfeSafety's Tech Tips. Tonight we're going to be talking about surge protection devices, or SPDs. Now, surge protection devices are becoming more and more in fashion because now we're using devices that are of a lower voltage than before. They're not the 220 to 120 volt bells and horns and strobes that we used to use years ago that, they could take a beating if there was a lightning strike or a voltage transient. Today's electronics, cameras are working on a couple of volts. They run off a 12 volt DC power. Telephones are connected to the Ethernet. Devices that are on the Ethernet are, if they're powered off the Ethernet, they're powered off of 48 volts DC. They got 5 volt data streams running on them. Very low voltage. Doesn't take a really big spike to take some of these devices down. So surge protection is becoming more and more necessary in our daily lives. Not just for fire and security, but for everything that we use electronic wise. So one of the questions I get a lot is there a single device I can buy that's going to protect me, all my different types of devices? And the answer is no, unfortunately not. There isn't. Your decision making needs to be a little more, you need to be more informed. You need to know what you're protecting and how well you want to protect it. And how much money you want to spend to save how much money from products going down. First thing we need to know is what kind of products are out there that are going to be doing the protecting of your devices. What kind of discrete components are used in most of the surge protection devices that are in the market today. And basically there's three of the most common anyway. The first one is an MOV, or a metal oxide varistor. Metal oxide varistor is a very fast reacting device. It reacts within nanoseconds. So that's the good of the MOV. The bad of the MOV is it has really low current carrying capacities. So if you have a very, very large spike, you're going to end up with a toasted MOV. Possibly, you're probably going to have a protected device because when they fry like that, they short out and they shunt that entire circuit to ground. But now you got to replace the surge protection device because it's fried. The second type of device that's out there is what's called a TVS, or a transient voltage suppressor. It's a diode. It's a Zener diode. Some people call them avalanche Zener diodes. And what they are is they're a diode that is meant to hold back voltage to a certain degree. In other words, if I have a 24 volt Zener diode, it's going to block 24 volts and lower. Anything above 24 volts, it's going to stop passing through. So it makes a pretty decent transient voltage protection device because anything over the rated voltage is going to be shunted out to ground. Now, the TVS is a very, very fast device. Those things react within picoseconds. They have medium current carrying capacities, so they're not going to burn out like an MOV will. And as long as you don't go over the rated current of the device itself, they're restorable. So they'll take a hit. If they haven't been burnt out, when the transient goes away, everything goes back to normal and they're there ready to protect you against another hit. So you don't always have to keep buying new transient voltage protection. The third is a GDT, or a gas discharge tube. Now that's filled with an inert gas. It's a tube filled with inert gas and a couple of electrodes. And what happens is that basically shorts out when a large transient comes through. Now, these devices are relatively slow. They take around 100 nanoseconds to react. But they get extremely high current carrying capabilities. Extremely high. These are the kind of devices you have on surge protection devices that are protecting you against lightning strikes. And again, if they don't get blown off the board, when the surge goes away, everything goes back to normal, and they're sitting there waiting to protect you again. They're self-restoring. All right, so what do we got? We got three different types of devices Some are really fast with really low current capacity. Some are really slow with really high current capacities. So what's the best answer? Well, the best answer is a hybrid approach. A lot of the manufacturers of these surge protection devices now are using a hybrid approach and using combinations of these devices to give you the best protection based on the type of circuit that you want to protect. For instance, do we need speedy reaction, but we don't have a large current carrying capacity? Possibly. Something like an Ethernet connection. An Ethernet connection very rarely sees the outside world. Most of it stays inside the building. It'll never see lightning. So the transients you're going to get on an Ethernet are relatively low. So you can get away with a combination MOV and a TVS. An MOV is very fast. The TVS has medium current capacities, so they can work in concert together. The MOV can grab the transient quickly, and before it burns out, the TVS will pick up and pass the current through. So it's a combination effect that gives you the best protection. Now, what about Ethernet that goes outside the building? That does happen. There are IP cameras hanging outside of buildings all over the place. So there is going to be a section of internet, or not internet, but Ethernet, that goes outside the building. Well, then you change strategy. Now your strategy is going to be, I need high carrying conductivity because that thing's going to attract lightning. So that's when you're going to use a hybrid of TVS and GDT, the gas discharge tube. So that's going to give you the speed of the TVS to pick that transient up, and then by the time the transient protection or the TVS is getting to its limit, that gas tube's taken over and takes up all that current. So it's a hybrid type of engineered device, and they work great. They work fantastic. Voltage rating is important. Telephones work at 48 volts. Fire alarm systems work at 24 volts. And there's a myriad of different types of voltages in a fire alarm system. There's regulated and unregulated power. There's the signaling line circuits that carry not only 24 volts power, but data. So you got to be careful what circuit you are putting these transient voltage protection on, because I've seen fire alarm systems with notification appliance circuits that are unregulated that are at 28, 29 volts DC in normal condition. They do that because it's unregulated. That way, when they start drawing current off it, that voltage can drop down and it'll settle down at 24 volts with a good amount of current being taken out of it. Well, if you put a 24 volt transient protection device on a 28 or a 29 volt DC circuit, that extra 3 or 4 volts is going to start tickling the TVS in there, or most likely it's going to be a TVS. It's going to start conducting. Well, as it starts conducting, you're doing a couple of things. First of all, you're robbing it of life because you're making it work harder than it should for a long period of time. And the second thing is, and all you technicians know, you start leaking voltage on the ground, what's it going to give you? A ground fault. And everybody loves ground faults. So it's very important to make sure that you have TVSs that are above the rated voltage of the circuit that you're on. It doesn't have to be a lot. If you have a 24 volt DC circuit, you can put a 32 volt transient protection device on there. I don't know of any fire alarm that can't take a 32 volt spike. All right, they're made to take 1200 volt spikes off the shelf out of the factory. So if you put a 32 volt or a 38 volt transient protection device on a 24 volt circuit, you're covered. That 24 volts is never going to tickle that TVS. Everything's going to stay off until something big comes. And then it's going to protect your system. So voltage is very important. All right, and in your decision-making process, you need to be smart. If you have cameras that you're trying to protect, buy TVS products that are made for cameras. If you're going to have Ethernet that you're going to protect, buy the surge protection that's going to protect an Ethernet product. They make them specifically for the different kind of systems that you have out there. IP telephones, that's all Ethernet. That's all 48 volts. Buy the Ethernet protection devices. You can't go wrong. All right. We've talked about small voltage circuits, 48 volts, Ethernet and telephones. We've talked about 12 volt cameras, 24 volt fire alarms, 12 volt security systems. All right, I really didn't talk about the 12 volt security systems, but they're out there. What about the higher voltages that we have to worry about? What about this lightning that hits the building and gets into the building? Well, there's a few things we have to be careful of. We talked about the cameras hanging outside. You also, in the fire alarm world, you always have a beacon outside the building. That's going to be a target for lightning. There's always going to be something out there that's going to attract lightning. You may have a gate opening system on a card access panel. Anything that's outside is susceptible to lightning. That's big time voltage and current coming into your panel, doing all kinds of damage. So what you want to make sure you do is you want to protect your panel, you want to protect your building as much as you can. And that, first of all, starts with the type of device that's the best for clamping down quickly and removing the transient and stopping the transient from getting to your system. Now, some transient devices are meant to run on the 120 volt system, and you're told to take that and put it in the panel and run it to a ground near the panel, and when the voltage comes into the panel, it'll stop it right there and nothing will happen to your system. Okay, they probably work to a certain degree. But some of the smarter manufacturers are making products that go out at the breaker box. The ones that go out at the breaker box, they get the transient protection long before it gets out to the fire alarm panels. Surprisingly enough, these high voltage transients don't travel at breakneck speeds. They can be caught and stopped before the full inrush of the transient gets through. So these devices at the breaker box will catch the spike as it comes in the building and hits the breaker box, and either disconnect the wiring to the control panels through relays, or by shutting down the breaker, or not shutting down the breakers, but popping the breakers and disconnecting the control panel from the wiring. We do it at the breaker box. It's a lot quicker, it's a lot smarter, and it's a lot easier. The other thing that's a lot easier to find at that particular point is a good ground. Because if you have the breaker box is in a mechanical room where all the electrical services for the building are, and you got a fire alarm out in the front lobby, the ground out in the front lobby is not going to be that great. Earth ground is the single most important aspect of surge protection, absolutely without a doubt. Every piece of surge protection takes the transient, shunts it to ground. Bar none. There's no such thing as a transorb that shoots the transient out into the air or into a lake or across the street. It shoots it in the ground. Everything is shed to earth ground. If you don't have a good earth ground, then the panel's going to the transient's going to search for ground, and it's going to search for ground through your telephones and your computers, your fire alarm, your card access system, whatever you got. It'll find ground somehow. A wise old man once told me that no amount of product can fix bad wiring. Thank you, Mike Agri. It's the truth. If you have a lousy ground, your protection against surges is going to be lousy. You need to make sure that your building has a minimum of 25 ohms to ground. Call an electrician, they know how to measure this. They'll put ground rods in the ground, they'll measure the potential. 25 ohms is the magic number, or lower. Low impedance. And if you have several places where maybe you have breakers in several different locations in your building, you got to make sure they're all bonded correctly. So they're all at the same ground potential. Because you could have a circuit being powered out of one breaker box, grounded to the ground of another breaker box that might be at a completely different potential, and it's just not going to work right for you. So grounding and bonding, very important in your building. So there you have it. You got quick devices that can carry very little current. You got slow devices that can carry all the current in the world. You got hybrid design. You got all different kinds of circuits that you want to protect. And we have the product on our website for you to use. Do your research. Check out our website. Take a look at what's there. If there's any questions or any confusion, the phone number's there. As a matter of fact, it's tap dancing across the bottom of the screen right now. Give us a call. We have the expertise. We'll guide you in the right way to protect whatever it is that you want to protect. So with that, I say thank you and have a life safety day.